Okay, so guys, we have a couple strategies under our belt, right? We have graphing, where we have both equations that are y equals, right? We have substitution, where we see either a single x equals or a single y equals. Today we're going to look at elimination. Okay, so remember the name of the game with substitution was we took two equations with x and y both, substituted something either in for x or y to make one equation with one variable, either just x or just y, right? That's what we want to do. So here with elimination, we are either going to, shocker, eliminate x or eliminate y, so that then we just have one equation with one variable, and we can move forward from there. A lot of kids really like elimination because it eliminates stuff, so it generally makes the problems easier. Okay, a lot of kids tend to lean this way versus substitution because remember with substitution, we're plugging an expression in, which sometimes can make the equation a little more complicated to solve. But with elimination, we're cutting stuff out. Okay, so a lot of kids prefer elimination, especially when it's set up that way. Okay. All right. So what I want you guys to do is I want you to try to work through exploration 1, parts A and B. Okay. Work through exploration 1, parts A and B. Go ahead. Okay. So let's see what we can make of this first exploration here. So it tells us information about you. And it tells us information about your friend, right? So I'm going to write a separate equation for you and your friend, okay? So it whoa. All right, so it tells us exactly how to write our equations. Number of drinks times the price per drink. So it looks like, what do we not know in this problem? We know some information, but we don't know some information at the same time, right? What do we not know? Yeah, the price of the drink and the price of the sandwich, right? So it tells us to use X for the price of the drink and Y for the price of the sandwich, okay? So the number of drinks, it looks like you have one drink. Sorry, let me pull out my pen. There we go. Looks like you have one drink times the price per drink, which is X, plus the number of sandwiches. You purchase one sandwich times the price of the sandwiches. And it looks like your total bill is $4.50, right? So that's you, okay? The second equation, your friend, it looks like he or she purchases one drink, so 1x, plus 5 sandwiches, who knows why, 5y. And they paid $16.50. Okay? So it's asking us to subtract these equations from each other. Okay? If I had to subtract these equations from one another, so let me stack them up. So now I have 1x plus 1y equals 450. And I have 1x plus 5y equals 1650. Okay? I don't ever like, so this is just a little caveat that kind of is personal to me in my classes that I teach. Some teachers teach that it's okay to subtract. I don't like it. Okay? I don't like to teach you to subtract because I just feel like it's more confusing. Okay? It is not incorrect, but it is definitely more challenging to subtract rather than do the way that I'm getting ready to tell you, okay? So let's think about the concept of elimination. Can somebody tell me two numbers that if I added them together, they would eliminate each other? If I add them together, they would eliminate each other. Yep.
Negative 10 and 10.
Negative 10 and 10. What else? Yeah.
Negative 9 and 9.
Negative 9 and 9. 5 and negative 5. 2 and negative 2. A million and negative million, right? Any opposite numbers are numbers that would eliminate, okay? So we're going to create opposites. That's kind of what they were getting at when they said subtracting, right? Because if I did 1x minus 1x, that would eliminate, right? But instead of subtracting, I'm going to just show you to multiply by a -1. So you're essentially looking for opposites. And I'm going to create opposites if I don't have them. Okay? So in this case, since you have 1x and 1x, it doesn't matter. Which one would you like to multiply by a -1? The top equation or the bottom equation? Anybody have a preference?
Bottom.
Bottom? Okay. All right, so we're going to multiply this bottom equation by -1. Okay? So let's just rewrite my function here. I have 1x plus 1y equals 450. Right? That didn't change. The bottom equation got multiplied by a -1. So -1 times 1 is -1x. -1 times 5y is -5y. And -1 times 1650 is -1650. Okay. Now do you have opposites? We have opposites on the x's, right? So now we're ready to add down. You always add down. So 1x plus a -1x is eliminated, right? That's what I wanted. 1y minus 5y is -4y. And then 450 plus a -1650 is going to leave you with 12. -12, excuse me. So I create opposites. I add down to eliminate. And now I just need to solve what's left. So I divide by -4. And I end up with y equals 3. What does that mean?
The price of the sandwich.
The price of the sandwich, right? Because if I go back up to the original problem, it tells me y is the price of the sandwich. Does anybody have an idea of how we could figure out now the price of the drink? Yeah.
You use your equation, friends. Use your equation and with your drink and sandwich is $4.50, and then you subtract $3 from $4.50, and it's $12.50.
Yeah. So essentially, what he just explained is the process of taking my y value that I just found. This is very similar to the substitution that we did last class. I take my y value that I just found, come back up to one of my two original equations, and plug it in for y. I think definitely your equation versus your friend's equation is going to be easier. So we have x plus y, which now we know y is 3, equals the 450. I subtract 3 from both sides, and I end up with x equals 150. Okay, so now let's go ahead and interpret. So I'm just going to pull it over here, and I'm going to say 150 per drink and $3 per sandwich. Okay, it's always important that anytime we have a real life situation with context to it, that we take the answer back and put it in context of the problem. Okay. All right, so this is the concept. Okay, this is the concept. Once you have your two equations, you multiply. So that's what the steps down here are. You multiply either one or both of the equations to create opposites. Once you have opposites, you add down to eliminate one of the variables. You solve for whatever's left, and then you substitute back in to find the other one. Okay? All right, so let's look at the second page here. I uploaded my notes kind of weird, so I think I'm going to have to delete this page. And all this stuff. All right, there we go. Okay, so now we're on page 2. Let's have you do, actually, I'm going to do a couple with you, and then I'm going to have you do the rest, okay? All right, so let's look at number 1 first, okay? So if I'm looking at number 1, first question I should always ask myself, do I have opposites? So do you see that either your x's are opposites or your y's are opposites? Yes or no? Yeah. Yes. The x's are opposites, right? Positive x and negative x. So I am ready to add straight down without any more multiplication happening, okay? So now I'm ready to add straight down. So positive x and negative x, when I add them together, eliminate. 3y plus 2y is 5y. 17 plus 8 is 25. So I add straight down. Once I've eliminated one of the variables, I solve for what's left, so I divide by 5. And I have y equals 5. Okay? Then I need the x value to go with it. Okay? So, would you like to use the top equation or bottom equation to find x? Yeah, I'd probably pick top, right? Because it's a positive x. So I have x plus 3. What's y? 5, because that's what we just solved for, equals 17. Okay? So we have x plus 3 times 5 is 15, equals 17. Subtract 15 from both sides, and you end up with x is 2. So again, just like with graphing, just like with substitution, we need to make sure that elimination has an ordered pair answer. So it's going to be 2, 5. And remember, it's not what you solve for first, what you solve for second. It's always x, y. So 2, 5 here. Oh, didn't group it all together. Hold on. Wait, how do I do that? There we go. All right. Now I want to do number 10. Okay. So let's look at number 10. Okay. So again, first question you have to ask yourself, are there opposites? Do you see x's or y's as opposites? No. And guys, even if you see a positive number and a negative number, if they are not the same number, those are still not opposites, right? So we're going to have to multiply one of our equations, okay? So I can either, so let's talk through this. You always want to make a smaller number into a bigger number. You never want to chop it down, okay? So if I'm looking at the x's, I would have to leave this bottom 2x alone. So what would I have to make the top? If the bottom is 2x, what would the top have to be? To be opposites. If the bottom's 2x, what would the top have to be? Negative 2x. So what would I have to multiply this by to make it negative 2x? Negative 2, right? So I could either multiply the top equation by negative 2 to match up x's, or if I looked at y, same sort of process. I have positive 2y on top, so the bottom would have to be negative 2y, so I would have to multiply that by negative 2. Okay? So which would you prefer? Match up x's or match up y's? Either one's easier. Either one is easy here. The y's? Okay. So if I'm matching up y's, I'm going to leave this 2y. I'm going to make this negative 2y by multiplying the bottom equation by negative 2. Okay. So top equation stays the same. X plus 2y equals 20. Bottom equation gets multiplied by negative 2. So we have negative 4x. 2 times negative y is minus 2y. 2 times negative 19 is negative 38. Okay, now I have opposites. Now I'm ready to add down. Okay, so x and negative 4x makes negative 3x. 2y and negative 2y eliminate. 20 and negative 38 makes negative 18. Then I just have to solve what's left. So I divide by negative 3. And I end up with x equals 6. Okay, so there's half of my answer. The other half of my answer comes when I substitute in. So I would probably use the bottom equation since there's not a number in front of y. And you can honestly use either one. So I have 2 times x is 6 plus y equals 19. So 2 times 6 is 12. I subtract 12 from both sides. And I end up with y equals 7. So then my answer is 6, 7, x, y. Okay, can I get a comfort level of how you're feeling right now? 3, 2, 1, 0. Good. Okay. All right, let's do. Let's do. 3 and 12 together with your groups. Just do 3 and 12 together with your groups. Okay, go ahead. Okay, let's go ahead and look at number 3. Okay. So on number 3, do you have opposites? Yes, you do. So let's go ahead and add down. Okay, so my x's are going to eliminate. 3y and negative y makes 2y.
Yeah.
10 and negative 2 makes 8. Divide by 2. Y is 4. Okay, substitute it back in. I would probably pick the top one because I don't like messing with negatives if I don't have to. So 2x plus 3y is 4 equals 10. 3 times 4 is 12, so I'm going to subtract 12 from both sides. So I have 2x equals negative 2. Divide by 2. And x is negative 1. So that means my answer is negative 1 comma 4. Okay, any questions on number 3? Anything at all? Okay, let's look at number 12. Okay. On number 12, do I have opposites?
No.
No. So let's look at the y's. Okay. So I have negative 10 down here. So that means I would need to make the top positive 10, right? Is there any number I can multiply, any whole number I can multiply 4 by to make it a 10? Because I don't want to mess with decimals or fractions. Could I multiply 4 by anything to make it 10? No, so that's not a good option, okay? Unless you absolutely have to, that's not a good option, okay? Let's look at the x's. So the top one is bigger, that's 9. Is there anything I can multiply the bottom 3 by to make it a negative 9? Negative 3, right? It's a 3 already. I need to make it negative 9, so I'm going to multiply the bottom equation by negative 3. Okay? So now top equation stays the same, 9x plus 4y equals 11. Okay, the bottom equation I multiply by negative 3, so that's negative 9x plus 30y equals positive 6. Now I have opposites. Oops. Now I have opposites. Now I'm ready to add down. X's eliminate. I have 34y. And I have 17. Did I mess something up? Or is this supposed to be a 1/2?
I got 1/2.
You guys all got 1/2? Okay. So divide by 34 on both sides. And y is 1/2. Or 0.5. Doesn't matter which one you use. Okay. Then to figure out the x value, I would again use the top equation if I could. So 9x plus 4 times y is 1/2 equals 11. Half of 4 is 2, so 9x plus 2 equals 11. Subtract the 2 over. 9x equals 9. So x is going to be 1. So I have 1 comma 1/2, or 1 comma 0.5. Okay, any questions on those two? All right, let's look at one that challenges us a little bit more. Let's look at problem 17. Bless me, sorry. Let's look at 17, okay? So I'm going to challenge you, okay? I want you guys to see what you can do on this problem. See if you can come up with some kind of solution on how we could go about solving this problem. It's going to be more complicated than what we did on the other problems. But I don't want you to try to mess with fractions or decimals. That's the only hint I'm going to give you, okay? So I'm going to give you a few minutes to try to figure this one out. Go ahead. All right, what'd you guys come up with? Anything?
Nope.
I got some no's. Anybody come up with anything? Yeah?
What is wrong?
You could multiply the top equation by 4 and the bottom by 3.
So if I multiply the top by 4 and the bottom by 3, what would that accomplish?
You would get the y to be 12 and -12.
Good. So again, my goal is to match up opposites, right? Goal is to match up opposites, like 10 and -10, 5 and -5. I can't multiply, so on x's, I can't multiply 5 by anything to make it 8. On the y's, I can't multiply 3 by anything to make it 4. So I can't go that option of just multiplying one of the equations. So I'm going to have to make it a little more complicated and multiply both. So you really could do either way here. If you wanted to match up x's, you could make them both what? 40? Yeah, that'd be the closest thing, right? So you can make them both 40 and -40. Or with the y's, you can make them 12 and -12. I like Ashlyn's option of going for the y's. One reason is because it's not 40, right? It's a smaller number. Second reason is they're already positive negative, right? So if I ever have a positive negative pair, and I'm going to have to multiply both equations anyways, I might as well go for that positive negative pair, right? Because then I don't have to mess with multiplying by a negative on either equation, okay? So we're going to do just what she said. We're going to multiply the top by 4, the bottom by 3, okay? So now let's rewrite our system. So now we have 32x minus 12y equals -36. New bottom equation is 15x plus 12y. We see our opposites there, which is good, equals positive 36. So now I have opposites. Now I'm ready to add down. So 32x and 15x makes 47x. 12y, -12y eliminated, which is what we wanted. 36 and -36 is also 0. Okay, so I want to warn you here. If you're doing an elimination problem and you're looking for opposites, the numbers on the other side of the equal sign being opposites does not count. Okay? Because that does not help you eliminate either x or y. Okay? If it ends up like this problem in particular did, that's okay. That's fine. Okay? But if you're looking for opposites in order to eliminate a variable, the numbers on the other side don't count. Okay, so just be careful with that. So now divide by 47 on both sides, and you still get x is 0. So then figure out my y. I'd go for probably the bottom equation, so 5 times 0 plus 4y equals 12. 5 times 0 is 0, so that's out. Divide by 4 on both sides, and y is 3. So I got 3, 0. Oh, Mr. Craw about did a big oopsie. X, y, 0, 3. Okay. Any questions?